marginal cost, or C prime X, is the rate of change of the total cost per unit change in quantity X. For this example, a specialty item manufacturer determines that the cost of producing X ballpoint pens is CX equals 500 plus 3X in dollars. Find C at 101 minus C at 100, which is the cost of producing the 101st pen. To compute C at 101, we replace X with the 101 to get 500 plus 3 times 101. That will give you 803, and the cost at 100 is computed similar way. So 500 plus 3 times 100, or 800. Therefore, the difference of C at 101 and C at 100 equals 803 minus 800, or 3. It means the cost increased by $3 for producing the 101st ton. Next part, find C prime at 100, which is the marginal cost at X equals 100 pence. Cx is 500 plus 3x. So C prime, or the marginal cost, is the derivative of 500, which is 0, plus the derivative of 3x, which is 3 times 1. Therefore, the marginal cost at X is 3. And we compute the marginal cost at X equals 100. So C prime at 100 is also 3 because the Cx turns out to be the constant term. The marginal revenue is the rate of change of the total revenue per unit change in sales when the level of sales is X item. So we use the function Rx to represent the revenue. The marginal revenue will be R prime at X. In this example, suppose that a manufacturer has determined that the price of certain custom-made tables he produces can be determined by the demand function, the lowercase p as a price function, or the demand function, dx, as 117 minus x over 4, where x is the number of tables produced and sold. Part A, find the revenue function. Recall the revenue function is the product of the item produced multiplied by the price, which is the dx. So we get x multiplied by 117 minus x over 4, or 117x minus x squared over 4 as a revenue function. And next, we will determine the marginal revenue when x equals 16 tables. So the marginal revenue is R prime, which is the derivative of 117x minus x squared over 4. I'm going to write it in this form. D by dx of 117x minus x squared over 4. So the derivative of 117x is 117. Derivative of negative x squared over 4, as negative 1 over 4 is the coefficient, and the derivative of x squared is 2x. Therefore, we get R prime x, or the marginal revenue, as 117 minus 1 over 2 times x. For x equals 16, so R prime at 16 equals 117 minus 1 over 2 times 16, or 117 minus 8, or 100 109. It means the revenue is increasing at a rate of $109 per table as the 16th table is sold. The marginal profit. The profit is represented by the capital PX function. The marginal profit is the rate of change of the profit per unit change in sales when X items are produced and sold. So the marginal profit is represented by P prime X. And recall the profit is the difference of the revenue and the cost. That tells us P prime X can be found by R prime X minus C prime X. In this example, if the table manufactured in the previous example has a cost function of Cx equals 225 plus 2x squared, along with its revenue function of Rx equals 117x minus x squared over 4. Find part A, all break-even points. Part B, the marginal profit when x equals 10, x equals 20, and x equals 30. To find the break-even point, the break-even points occur where Cx equals Rx or when the cost equals the revenue. The cost function is 225 minus plus 2x squared, and the revenue function is 117x minus x squared over 4. We are going to solve this equation. First of all, multiply all by 4 to get 225 times 4 or 900 plus 4 times 2, that's 8x squared equals 117 times 4 or 468 times x minus x squared. Multiply this by 4. And then collect the terms, move every term to the left-hand side by adding x squared both sides to get 9x squared, and then subtracted by 468x both sides to get negative 468x plus 900 from the left-hand side equals 0. Then we factor 9 out of those three terms. So we have 9 times x squared minus 52x plus 100 equals 0. And next, we are going to factor completely. X squared from x times x, 100 is from 50 times 2. Both have the same sign because the product is positive, but the sum is negative 52. Therefore, the factor will be x minus 50 multiplied by x minus 2 equals 0. We get the two break-even points, which occurs at x equals 50 and x equals 2, as you see on the graph on the right side here. The cost function and the revenue function intersect at 2 points at x equals 2 and x equals 50. Next part, we are going to find the marginal profit. Before we find the marginal profit, first set up the profit function. The profit is from the revenue minus the cost. So the revenue function is 117x minus x squared over 4, subtracted by the cost function, which is 225 plus 2x squared. Take away the grouping symbol. 117x minus x squared over 4 minus 225 minus 2x squared. And combine like terms, simplify the numbers to get negative 117x, positive, sorry, 100 plus 117x minus 225 and minus 9 over 4 x squared from combining negative x squared over 4 and negative 2x squared. So this is your profit function. And next, we're going to find the marginal profit, which is P prime, or the derivative of the P function. The derivative of 117x gives us 117. The derivative of negative 225 is 0. The derivative of 9 over 4x squared is 9 over 4 times 2x, which is the derivative of x squared. Therefore, the marginal profit, or P prime x, is 117 minus the 2 and 4 reduced, minus 9 over 2 times x. And then we are going to find the marginal profit at 10, at 20, and at 30. The marginal profit at 10 is 117 minus 9 over 2 times 10, or 117 minus 45. That gives us $72. For the marginal profit at 20, it's computed by 117 minus 9 over 2 times 20, or 117 minus 90 gives us $27. And the last one, marginal profit at 30, is 117 minus 9 over 2 times 30, or 117 minus 135, or P prime at 30 is negative $18.